assuming it didn't fail, the next thing we need to do is begin to populate our vertex buffer with the vertices that we defined earlier. And we can do that using this here. Basically we define a void pointer. Void pointers are always seen as dangerous, but I think it's probably one of the only ways you can do it here. And we need to get our pointer to our newly created vertex buffer and use it to lock the vertex buffer. We're going to lock it so no other process can change the contents of that memory while we're dealing with it. So it's locked now. It's restricted from any other process apart from what we want to do with it. The first parameter there, the first argument, is the beginning of the vertex buffer. Where do we want to lock it? At which point do we want to begin? And we say not because we want to lock the start of the vertex buffer. This is the end of the vertex buffer. We want to lock from the start 0 to the end, which is the size of verts. And if you remember verts here, verts is the data structure that holds all our vertex information, so we're going to lock enough memory in the vertex buffer just to fit our vertex information. This is the output. Basically this is going to return the pointer to the vertex buffer so we can begin to write data to it, and I'm not really sure what that does. Look it up. Again, we're going to return eFail if it failed so we can detect it. It's basically like throwing an exception, I suppose. Well, not really, but you can kind of think of it like that. Right, once we've got it locked, we can begin to work with our vertex buffer, and we do that using well, basically it's easy. We've got our pointer to the vertex buffer, so we can just copy our vertex information into the vertex buffer using the pointer to it. So it's just simply a mem copy there. We're just going to copy over our vertices data structure into our vertex buffer, and this mem copy is standard C basically, so you should know what this is. I'm going to copy that much over to there from there, and then finally to round the initialization method off, we just need to lock our vertex buffer again so we've finished writing to it. Return SOK, which is the signal we're going to throw the fact that it worked, which we can detect with the succeeded macro, which we will use later, so I'll show you what that's about. And basically, if we look at this method again, it just creates our vertex information using the struct that we defined here. It creates the vertex buffer to hold that information. We lock the buffer and then copy the information into it, then unlock it and return SOK. Pretty simple. It may seem quite complicated, but once you've done it enough, you know, you get your head around it. The next method that we're going to implement is our render method. Here we go. The first thing we want to do is tell the graphics card that we're about to send it some data. This is the succeeded thing that I was just saying there. Return SOK, you can detect succeeded. So if this works, you know, if the graphics card says yep, send me some data, and then we can detect that with the succeeded macro and head into this if block. Right, so the graphics card knows we're about to send it some stuff. So 1 second, just grab what we're about to send it. Right, so the first thing we've got to do is hook up our graphics card to the vertex data contained in the vertex buffer, and we do this by setting a stream source. It's called on the method. It's a method of the D3d device, and we're going to set the stream source, basically telling the graphics card, you know, this is where our data is, this is where our buffer is. Again, we'll go through this line, parameter. The first parameter here is a stream number. We can have multiple streams if you want, and send data, multiple streams of data into our graphics card, and we can do that using stream numbers. This is essentially just stream number 0 because it's the first one we've got. We aren't doing any other streams, so we can just set this to 0, saying it's the first stream. This is the data that we're going to send. This is the beginning of the buffer. This works the same as the vertex buffer earlier. This is the beginning of the data, and this is the end of the. This is actually the size of each individual vertex. So this is the step. So we're going to begin at 0 and step through each vertex by this number of bytes, basically. So basically, we're going to hook the graphics card up with the vertex buffer, with this vertex buffer, using stream number 0. It can begin at byte number 0 or bit number 0, and each vertex is going to be that size, so we can step through each vertex one by one. Once we've done that, we also need to tell the graphics card the format of the data that we're going to send it. So again, we can use the myFEF definition there, which basically says the format of the data is going to be position followed by colour. And we use the device, you know, to send that information, saying it's going to be position followed by colour. The next part is we're going to actually send the data to the graphics card, so it can be the graphics card can deal with it. This is done with the draw primitive method of device. We're just going to say the primitive type is a triangle list, so we're sending essentially a list of triangles. One is in a list of triangles, a list of 1. We're going to say that the start vertex is vertex number 0 in the stream, and we're going to draw one primitive. We're going to draw one triangle in the triangle list. Simple as that. And then, providing that worked, which it will, we need to tell the graphics card that we're done. We're not going to send any more information to it. And then we're going to return SOK, saying yep, it worked, we drew what we needed to do. And then we will close our if succeeded. So if this couldn't happen, we're just going to return the fail, so we can detect that we couldn't render anything, and then close up that method there. Simple as that. Just run through it again. We'll tell the graphics card we want to draw things. We will hook it up with the vertex buffer. We will tell the graphics card what format the vertex is going to be coming as, so it can interpret it correctly. We will send the graphics card our data. Say it's a triangle list and there's going to be one of them, and then we'll say yep, that's it, we've sent all we're going to send for this frame. And then the last method is just simple. If you remember in the earlier tutorial number 1, I said that anything that begins with an I, so if we load up app.hpp again, we've got 3 things that begin with I here. We've got I, Direct3d 9, this one, and this one. We need to release at the end, so this is just a cleanup method which is going to release everything once we're done with them. So we just detect if it's there. If it's there, we'll release it for each thing, for each interface here. Simple. Right, we're nearly there. Essentially, that is app.cpp. We just need to change a few things in our WinMain.